Hi, fifth graders. We're on 510 and we are going to distinguish between multiplying and dividing. This lesson is a little tricky, so you may have to watch this video more than once or practice a lot in your Fat Cheetah book, which is I'm on page 193. I'm going to go through them and a couple of examples and show you whether we should multiply or we should divide. Okay, we have a turtle in this first problem who walks 2/10 of a mile in 1 hour. So if the turtle can walk 2/10 of a mile in 1 hour, how far will it walk in just half of an hour? It sounds like it should be division, right? I'm going to cut this in half. But in reality, the operation that we will do is we're going to multiply. Here's why. To get our answer. The question is asking you, what is 5/10 of 2/10 of a mile, which is how far he can walk, and of means multiply. Okay, so if this is what he walks in 1 hour, I want to know what the turtle can walk in half of that amount of time. So what I'm going to do is I'm going to multiply 5/10 times 2/10. 2/10. Okay, I'm going to multiply here. And 5 times 2, again, when I multiply decimals, the decimal goes out into decimal island. I'm not going to think about it. So one move there, 1, 2. So I got to do 2 moves for it to come back in. And 5 times 2 is 10. 2 moves for this to come back in. 1, 2 would be right there. Okay, and that makes sense. If I took 2/10, that's 1 hour. That's how far you can go in 1 hour. In half of an hour, half that amount of time, this should be half the number. Okay, which would be like dividing by 2, but instead we multiplied by 0.5, which is 50, like 50 over 100, 5/10 or 50 hundredths, which is a half. Okay, so we did actually multiply to find our answer, which is 1/10 for number 1. Let's take a look at number 2. Gus ran 3.6 miles. And he took a sip every 9/10 of a mile. So how many sips did he take? So I'm thinking about 3.6 miles, that's a long way, and he took a sip at almost every mile, almost. So like right there, right there, right there. So that cutting up action sounds like it's division, okay? So I'm going to take my 3.6 miles that he ran and divide it by the 9/10 of a mile. Okay, so this problem is division. Now, when I divide decimals, I cannot have a decimal in the divisor. So I've got to move that over. I'm going to move the decimal place once here, which means I will move it once here. So I'm going 9 divided by 36, which is 4. Easy. And the answer to this is, how many times did he sip? He sipped 4 times. This was a division problem. If you're not sure about what to do with the problem, I strongly suggest drawing a model. Okay, this is the 3.6 miles, and I would know that would be like 1, 2, that'd be 3, and there would be 4, but this is the 3.6 mark. And then I'd think about like, okay, 9/10 of a mile, 9/10 of a mile, and I'm cutting it up. So if I'm cutting it up, that's division. Let's take a look at number 3. There was a farm with lots of cows. So there was 135 cows, and those cows had calves last year. 135 cows had calves last year. This year, 6/10 times that many had calves. So that looks like less than a whole number. So the number was probably going to be less because it's 6/10 times as many. And this is saying times, which to me means I'm probably going to multiply. So, and I know that if I multiply these two numbers and this number is less than 1, this is less than a whole number, then that will mean my answer should probably be less than 1 too. So I'm going to take my 135 and I'm going to multiply it by this. And when I multiply decimals, I just don't. I send them to decimal island. So it's over there, 1 move, and I'll have it come back in 1 move. So 6 times 5 is 30. 6 times 3 is 18, 19, 20, 21. 6 times 1 is 6, 7, 8. and then I get my decimal back in. It was 1 to go out, so 1 to come back in from vacation, and it looks like 81 cows had calves this year. And that matches up because that is less. And when I look at this number, I'm also thinking that that's very close to a half, and half of this would be around like 70-ish, 76 or so, or 80, a little less, so that number is reasonable, okay? Let's take a look at the last one. Cereal, there's a box of cereal and it weighs 1.2 pounds. So if one serving is 8/100ths of a pound, how many servings would be in a cereal box? So I've got a big old box of cereal and I'm cutting it up into 8/100ths. Cutting it up, again, sounds like division. Oh, this was multiplied, I didn't put that. Okay, so cutting it up, number 4, sounds like division. And I'm going to take 1.2 and divide it by 8/100ths of a pound. And when I'm dividing decimals, I cannot have a decimal place in the divisor. So I'm going to go ahead and move that. Move the decimal over twice, which means I will move this decimal over twice. 1, 2. I'm going to add a 0 as a placeholder because there wasn't anything there. So now I'm working with 8 divided by 120. 8 goes into 12 once. And I'm going to bring down my 0. 8 goes into 45 times evenly. So, looks like there is 15 servings in that box of cereal. In the last problem, and I did not have room to write it here, there's a area problem. It gives you the area, it gives you the length, and it's asking for the width, or it gives you the width and it's asking for the length. Anytime you have an area and a width or a length, and it's asking you for the other part, you're getting a big number and a smaller number. It's asking you for the other smaller number, so that's another division problem. So when you're trying to distinguish between a multiplication and a division problem, I recommend that you draw a model, especially if you're not quite sure what the question is asking. And once you draw it, if you're cutting things up, you know you're probably going to do division. And if you're adding things together or making things more, that's probably going to be multiplication.